Continuing from the introduction to classes and objects, I've gone ahead and set up a file in VS Code in my lessons directory named classes_objects.py. And here's where we're going to set up an example of our class. And so we can add a docstring to it as well. So models a pizza class. And this is otherwise very similar to the example we left off with. So I'll encourage you to go ahead and pause the video here and add this class definition as well as some calls, and then go ahead and open it up in Trailhead so you can convince yourself that your code is successfully running. As a reminder, our class definition, everything inside of it is indented by one level, and these are our attributes, and this is our constructor or our initializer. And here's some usage of this class. So go ahead and pause the video here, catch up at this point, and then we'll talk through some additional capabilities in just a moment. All right. So again, just as a quick review, we're declaring a class here, and this declaration doesn't actually do anything. Although if we were to look in our Interact tab, we would see that we've got pizza with a capital P, and notice it's being bound to some class. And then notice here we actually have a pizza that's being bound to some object. And this is a pretty confusing and cryptic looking sequence. Pizza object at OXFF7C29. Well, this is actually a memory address. And this is what's really going on behind the scenes when we write something like ID1, for example, in this for this object. Behind the scenes, the computer's keeping track of a much larger value. This is in a format called hexadecimal, which you'll learn about in a future course. But F is actually the number 15, is a digit 15. So this is a very large number. If you imagine it's 870 and then a lot of additional complexity beyond that. So our memory is massive, the way that we think about memory. But nevertheless, a pizza is an object that we constructed down here on line 17 that's somewhere in our heap. This is specifically where it is. That's why we don't keep track of it in our diagrams. We just write ID 1, 2, and so on. Okay, but back to the example. So these are our attributes. So I might make a comment here. Attributes, all pizza objects will have. And then we have our init method. So this is a special method. Notice it's declared at a level of indentation within the class. We know that it's special because in Python uses the double underscore or dunderscore surrounding some name to say this has meaning specific to Python. It's reserved for Python's usage. And we can add a docstring here as well. This is just like a function, but it's defined in a class, so we call it a method. And this method's declaration or docstring will have, say, constructor fully initializes attributes. Right? So these were our attributes, we declared them, and here's where we're actually initializing them. And this self parameter is special. It's the one parameter that we don't add a type to because we know its type is going to be pizza, right? So we know that we're going to have a pizza type. And as we saw in the previous lesson, when we construct a new pizza object by calling the pizza constructor, again, if we were to hover over this, we see that pizza is bound to a class definition. So when we call a function, or when we have a function call, but it's actually bound to a class and not a function definition, we look and we see, does it have an init method defined? Yes, it does. Well, this self is going to be a reference to that object on the heap, and we're going to initialize it here. And so in fact, I think it makes sense to try dropping a breakpoint here. I'm not sure why that's giving me some trouble. Let's try this. Let's see if this actually works. So I try running this. Okay, yeah, great. And what you'll notice is if we were to trace and look at our call stack, so we go down to the one with the bug on it, and we see, okay, at the module level, if we click on that, at our module level, this is globals, we see that our line is 19. And then we're going into the init call, and notice that self is bound to a pizza object, right? So this is the pizza object we're constructing and initializing. This is what we diagrammed in the previous lesson. And if we step over this line, line 14, now notice we have self.size is medium. So we've initialized the size attribute. Similarly with toppings and similarly with extra cheese. And notice that when we come back, when we return from this, what we're getting is a pizza is bound to a new pizza object, right? And so now when we go and we print out what's the a pizza dot size, that's why we get medium, topping 0, extra cheese false, right? So if this was all the work we did just to construct one pizza, we wouldn't be doing ourselves much of a favor, right? We wouldn't have saved anything. It seems like we just added a lot of code to keep track of 3 variables. Well, let's maybe make another pizza. So I won't be creative with this variable name. Another pizza is another pizza object. We construct a new pizza object on the heap. It's going to have these defaults, right? And so now we've got 2 pizza objects, and let's customize this pizza. So another pizza dot size is going to be assigned large, and let's say it has 3 toppings. Cool. If we wanted to convince ourselves that these values were actually being set, you could imagine, wouldn't it be nice to print another pizza and get something meaningful? Well, we could try this out, and then oops, my debugger's point still set, so I'm actually gonna press the play here, and notice we actually come back to this twice because that's the second pizza object being constructed, and I'm gonna remove that breakpoint. But if we were to do that, we would see, oh, we get that strange output. So we'll learn how to make nicer string outputs of our objects in just a moment. But if we were to print both of them, actually, this is a good little comparison. So let's print a pizza. Okay. And I printed a pizza. And let's just talk about this for just a moment. So notice these numbers look very similar, 4Fs, but then they're different. And so these are 2 objects stored at 2 different locations in memory. On our heap in our diagram, we would have 2 pizza objects living in the heap, each with their own IDs, and now each with their own attributes. And so the attributes of a pizza would be, the defaults that we set up, medium, 0, and false for size, toppings, and extra cheese. With another pizza, we've changed those, right? And so if we think about conceptually, we've got 2 different objects. They're these bundles of variables. And now we can think about these objects that we can pass around. Like we could write a function that we pass a pizza object to, and it would have all of those variables bundled together, rather than having to pass 3 individual parameters like we've seen before. Now, another reason why classes and objects are valuable is we can add methods. And you've seen methods before of classes and objects, right? So you've seen, for example, if you have a list of x's, 1, 2, 3, and x's.pop index 0, right? This is a method, and we learned that this is a method call on the x's object. Well, pop is a method defined on the list class. So how can we define a method on our pizza class? Well, let's add a new definition. So a function definition, sorry, a method definition. And it's common to confuse this terminology, but it's important to distinguish between them. Even though def is what defines both a function and a method, the key difference is a function lives outside of some class definition, right? It's defined beyond a class, whereas a method is defined in a class. So it's like a function that's defined specifically within a class, and it has one more special feature, which is it needs a first parameter named self. And so let's define a method named price, and it's going to have this parameter named self, and it's going to return to us a floating point value, right? And here I'm going to actually turn it over to you to try implementing a price method in just a moment. But for now, let's just make this a skeleton of an implementation. So return 0.0. Right, we know this is an incorrect implementation, but this will say calculate the price of a pizza. Cool. Now let's actually try calling this. And so to convince ourselves that our implementation is going to work or currently is broken, let's try changing our output down at the bottom. So print a pizza, let's do print f and do price, a pizza, and then this is going to be a method call to the price method, right? And I've got an error here. I just forgot a quote. Cool. And similarly here, let's make this an F string as well. So print price of another pizza. And notice we have a method call, right? So another pizza.price, a pizza.price. And what we're going to see is that when we call the price, I said prize, not price. When we call the price method on a pizza, whatever object a pizza is bound to. So in this example, we would have a class definition bound to ID 0, a pizza object for a pizza bound to ID 1. When we call this price method, the special thing about self is that it's going to be bound to ID 1. So in other words, when a method is called, whatever object precedes it is going to result in an ID, and that ID is going to be assigned to self. So then we can say, self.size, self.topping, self.extra cheese within this method definition to gain access to the attributes of whatever object this method was called on. So let's actually let's try making a simple example of that. But let's convince ourselves that this function is actually, or this method's actually being called. So we see price 0, 0 for each of them. Well, our logic is going to be if pizza is large, is medium, base price is, let's say, $10, large 15, per topping price is, let's say, 75 cents, and extra cheese is $1.50, right? And ultimately, we're calculating some price. So let's set up a variable named total. That's going to be a floating point value, and it's initially, let's say, 10.0, because that's the base price of medium. And let's not worry about small or any other options. And return total is what we're ultimately going to evaluate to. And now your job is to fill in the blank here, and I'll get you started with one quick example, which is an if statement. If self.size is equal to large, then total is going to be reassigned to be 15.0, right? And so we can go ahead and see if this is working. And of course, we see that for our first pizza, which was a default medium, we get back 10 from this price method call, right? So that's the output of this particular method call. And similarly, when we get the second method call, we see that its result is 15. And just to kind of prove one more point here, I want to set a breakpoint here on line 25, and let's try rerunning this program one more time. So when we rerun this program, we're paused at this point of price being called. And if we were to look at where did this come from, we would see that we were previously on, let's just do this for good measure. We would see that on line 37, this is in the module where we're being called. And now we're looking at this particular line, and we ask ourselves, what is self? Well, notice self is the pizza with size medium, extra cheese false, and toppings 0, right? And so that's a pizza, the same pizza object here, right? So in another cool thing in VS Code is if you hover over an object name, we see that, okay, this is the pizza with extra cheese false, size medium, topping 0. Similarly, and we look at what's self at this point in time, false, medium, 0. But another pizza in globals, we don't actually have a reference on yet because that hasn't been constructed, right? We haven't reached that point. We're only at this point, line 37. So I'm actually going to fast forward by pressing the continue button. So I'm going to continue back to this line. So we're back at the same line, but notice now our size is large, our toppings is 3, and that's because we're calling the price method on another pizza. And we see that another pizza, has these attributes. This is different from a pizza. A pizza is size medium. Another pizza we set to be size large. So these are two separate objects. And the second time that we called price on another pizza, you see that self is referencing that object, right? So we've got a reference to it, and that's why it's going to result in a different price once we continue on. So I'm going to remove that breakpoint, close my debug pane, and let you have a moment here to try and complete this implementation with the per topping and the extra cheese, and try proving to yourself that extra cheese calculation actually works by giving extra cheese to another pizza. All right. So how do we work with this? Well, total can be increased by self.toppings multiplied by 0.75, right? So we can use a little bit of arithmetic, and we're going to increase total by adding that amount of toppings to it. And then we can also test, if self.extra cheese is true. So, I have this default. It's a very natural thing to want to do something like this. And I show this because you don't need to, right? So the extra cheese is a Boolean value. It's always going to be true or false. And so when you're working with a Boolean value in an if statement, you don't have to compare it to true or false. True is always true. You don't have to say is true equal to true. True on its own is always true. So if this is true, we're going to increase total by 150 and return total again, right? So I'm going to save this method. I'm going to remove this comment. I'm actually going to make this just slightly smaller on my screen so that we can see, this method definition, as well as our call here. And so the first time we print a pizza.price, we kind of expect it to just be 10 because we had 0 toppings and we didn't have extra cheese. And sure enough, it was. But the second pizza that we set up, we gave it extra toppings and we're computing a price on it here. Right? Cool. Now, one of the reasons why we said objects are nice is because you can pass them around. So not only can we define a method like this, we can also, set up a function separate from this method or from this class definition. And let's say we wanted some, pretty print. And we give it a reference to some pizza, right? So here we're not going to use self as the parameter name. We'll use, let's just say lowercase pizza, and then uppercase pizza as the class type, right? So this is the name of a parameter. This is the name of a class. And so we use a capital P as a convention. If there's multiple words like pizza receipt, you would use subsequent capital letters to denote the next word. You wouldn't use underscores, but this is the type pizza. And this is going to result in nothing, right? So the point of this function is we want to just print out some information about this pizza variable or this pizza parameter. So I'm going to actually copy or cut those lines and then indent them that we had before. But notice, we were using a pizza before. So I'm just going to change this to pizza and do that. I'm going to copy and then paste here. All right. And so now we've got this extra function. If we were to look in our interact tab, we would see that we've got pretty print. It's a function. Notice it takes a pizza as a parameter. And this is one of the big ideas of objects is now we can also say, and actually, why don't we include the price here? So let's add one more line. We call pizza.price is the method called being evaluated. And so now we have our two pizzas, and we can also say, okay, pretty print a pizza. And here we are going to pretty print another pizza. And so notice this is just a function call. This isn't a method call. But what we're doing here is we're able to give a reference to an object, right? So we declared a parameter of type pizza, and now we can give an object of type pizza to that parameter. And when we save this and we rerun it, notice that we get size medium, topping 0, extra cheese, false, price 10. And maybe we want to print just some denotation. So that's the end of our little receipt there, right? And so our second pretty print, size large, toppings 3, extra cheese, false, and some price. So notice that in the definition of this function, we were able to give it a single object, and it takes that reference to that object and now has access to all of its attributes and all of its methods. And this is a really powerful capability because it makes it more possible to think about, okay, I want to give a full pizza object to some function, not 3 different parameters. What are the pizza's size, toppings, and extra cheese, right? And if you can imagine for objects that have many, many parameters much larger than this, for example, video games, your character has health, it has the attributes that it's assigned, that it's wearing as its clothing. It has the inventory, it has the power levels of hit points or damage. You've got whether you've got power-ups and special capabilities. Objects in games have tons of attributes associated with them. And so by being able to bundle them together and pass them around, and also being able to define some functionality, and we say, okay, every pizza now, when we have a pizza object in our function, in our program, it has the ability to calculate its own price. That's pretty cool. Now, I want to also step back a little bit and mention that the word object in thinking about classes and objects can feel a little bit funny. And rather than trying to put some bigger meaning, assign some larger meaning to them than is actually true within our programs, I think it helps to think of what literally are we talking about here. And so an object is literally just a collection of attributes that might have some methods associated with it. There's no more sophisticated, this is the program we wrote. This is all the sophistication the idea of a pizza has in our program, right? And that's enough, right? That's what we want, but it still can be kind of weird to think about. It's weird to say, a pizza is able to tell you its own price, right? That's kind of a funky capability of a pizza. You can't, in the real world, ask a pizza, hey, what is your price? Because that's not really what we're modeling here. Maybe a better name for this would be pizza order. And if I were to rename this, you could imagine that that's perhaps a better name for this particular example. But oftentimes we like to just put names like pizza or dog or cat or player in a game or things like that to our classes, and then just model their attributes and methods. We'll soon learn some additional capabilities. For example, we can actually make some functionality that makes string representations of our objects more nice to work with, so that when we actually print out, if we were to actually print a pizza, we can actually override this functionality of how are our objects turned into strings. We'll learn that very soon. And just to bring one more concept home, because I did mention this earlier, one of the downsides to what we were doing before is we couldn't have, say, a list of pizzas very easily represented when all we had were variables and lists. Well, now that we have classes and objects, we can actually say, my order is a list of pizza type, and it's just let's add these two pizzas to our list, and it's going to have a pizza and another pizza. Right? And so now we have this order. And if we wanted to calculate the total of an order, right? So order total is a float, and it's going to be initially 0. We could say for each pizza in order, order total is add up the pizza.price. So we can call that price method of the pizza that we're currently iterating through. And this is bringing together some concepts that we've recently learned, for-in loops. And now we can print, total is order total, right? And so, we get a total of 2725. And notice how cool this is. We're able to add objects to lists. And so we have a list of pizza. And that's a much more meaningful way of thinking about how we would model an order in a program than, we've got our list of toppings and our list of sizes, and okay, index 0 at each of those is going to be the same pizza. We could have done that before, but it's pretty cumbersome and less logically connected to how we want to think about solving our problem. And notice here that because we're looping through each pizza in our order list, we've got a reference to a pizza object, and we can call its price method. So this is an introduction in this video. We saw a little bit more on init. We played around with this price method. We looked at how we can pass an object to a function, and that gives us all of the attributes of that object as well as its methods that we can call on that object. And we saw that we can construct multiple objects of a class. So we can have hundreds of pizzas, thousands of pizzas, but we'll only have one class named pizza in this particular module. And we can use this because we've invented this pizza type. We can use it in places where we would expect to use other types. So this is a user-defined type to name pizza. And now we can do things like have a list of pizza objects and work with them in this way. So hopefully you get a feeling that we're able to build towards solutions that model the programs or the problems that we want to solve in our programs in a more straightforward way, in a more tidy and well-structured way.